All right, guys, welcome to Unit 2. This unit is all about reasoning and proofs, all right? It's going to seem kind of weird at first. It's not going to seem like it has much to do with geometry, but as the unit progresses, you'll start to see how it connects. So I hope you guys find this unit interesting. It's all about, how to reason, how to think logically, how to go through steps and make an argument, how to prove things. So it's a lot to do with critical thinking skills, and you're going to have to use your brain, okay? So we're going to start with this first lesson on inductive reasoning, and this video is going to be a little bit different than normal. You're not just going to write down everything that I say, okay? I'm going to ask you to pause it a lot and try some of this on your own, and so because of that, I'm not going to actually be answering every question. I want you guys to try and figure this stuff out, and then when you come to class next, we're going to talk about it. So because of that, I'm going to make the practice for this due this Sunday, all right, at midnight. So that should give you plenty of time, all right, so that we can talk about it in class and you don't feel rushed to do something you might not fully understand, okay? So we're going to start with inductive reasoning, all right, like I said. And what is inductive reasoning? Okay, so inductive reasoning, I'm going to write down this definition so that you guys can write down. All right, inductive reasoning is all about finding a pattern based on observations and then writing a conjecture. Sorry, I'm writing slow. I accidentally left my my stylus at school. So finding a pattern based on observations and writing a conjecture. So don't ever say, when are we going to use this, all right? Pattern recognition is super important, all right? It's going to help you make decisions in almost any job that you have, right? Finding a pattern and then using that pattern to make predictions is definitely applicable. Now, you might not know what a conjecture is, okay? So what is a conjecture? So a conjecture is an unproven statement based on those observations. All right, an unproven statement based on observations. So it's kind of like a hypothesis, all right? You're making a guess. You don't really know exactly if it's true or not. So we're going to look at some conjectures based on prime numbers, okay? And if you look at this box over here, a prime number is a number greater than 1 whose only factors are 1 in itself. So no numbers can divide into it evenly. So I want you guys to determine whether you think the conjectures here are true or false. So I want you guys to pause this video, all right, and read these two conjectures. The first one says the sum of two prime numbers is a prime number. Okay, so maybe look at a couple cases, all right, and see, is this true, okay, or is this false, all right, and how you would go about determining that. The second one says for any prime number greater than 2, the sum of that prime number and 1 is divisible by 2, okay? So again, I want you guys to pause the video, go through that conjecture as well, maybe look at a couple cases, all right, and see, do you think it's true or false? Okay, so hopefully you've gone through that. So we're actually going to talk about these now. So just so I can kind of show you what you're going to do. So this says the sum of two prime numbers is a prime number, all right? So if you think about the prime numbers, if we're going to list them here, all right, we've got 2, 3, 4 is in a prime number because 4 is divisible by 2. Okay, so then we've got 5. 6 is in a prime number. Then we've got 7. 8's not a prime number. Neither is 9 because 3 goes into 9. Neither is 10. All right, 2 and 5 go into 10. The next prime number is 11. So we're kind of, you can kind of see what these are. The next one is 13. No number goes into 13. All right. So the sum of two prime numbers is a prime number. So let's try a couple of these. All right, let's try the first two. 2 plus 3. All right, 2 plus 3 is 5. And as we said, 5 is a prime number, right? Because nothing goes into 5. So that case works. Let's try 2 and 5 next. 2 and 5 is 7. And we also listed 7 there. So 7 is a prime number. All right, no number divides into 7. The next one we could try is possibly 3 and 5, right? So 3 plus 5 equals 8. So is 8 a prime number? No, right? 8 is not a prime number. It's divisible by 2 and 4. So this is actually false. All right. So when you're doing this, you can't just look at one case. All right. You want to try, many different cases before you can say whether you think it's true. But once we found one that wasn't true, right, we could say, okay, this is false, right? 3 plus 5 equals 8. 8's not a prime number, so therefore that's false because we found an example that's it doesn't fit for, and we call that a counterexample. The next one says for any prime number greater than 2, the sum of that prime number 1 is divisible by 2. So we're going to go through these prime numbers, all right? 3 plus 1 equals 4, all right? Okay. 5 plus 1 equals 6, all right? That's divisible by 2. 7 plus 1 equals 8. That's divisible by 2. So the first 3 worked. Let's try some more. 11 plus 1 equals 12. That's divisible by 2. 13 plus 1 is 14. That's divisible by 2. So we've tried 5 cases, and maybe you decided before now or after now that you thought this was true. So we're actually going to say, okay, I think it's true, right? 5 cases, that's kind of enough. But we don't know for certain that it's true because we haven't proven it. Maybe there is a prime number somewhere that it's not true for, but for 5, we can say reasonably, all right, based on these observations, based on 5 trials, that we think it's true, okay? So it says, what is easier, to prove a conjecture is true or to prove it false? Why? So again, I want you to pause this and I want you to answer this question. Okay, so hopefully you answered that, and I think hopefully all of you said false, okay? Why is it easier to prove something false? Well, as soon as we found one example where it wasn't true, we immediately knew it was false, right? That's called a counterexample, like I said before. True is difficult, though, because we tried 5 and we think, it's probably true, but what if the 6th one we tried wasn't true? Or the 7th or the 8th? You could try 100 cases, but maybe the 101st wouldn't be true. So it's very hard to prove something true. You can't just do it with examples. All right, you would need some higher math to do that, and that's going to be kind of what we're going to be learning in this unit, okay? So it's much easier to prove something is false. So now we're going to look at a pattern, all right? We're going to try and make our own conjecture using the circles below. So it says on the first circle, draw 2 points, all right? Connect the points with a line segment. So we're going to go ahead and do that here. I want you guys to follow along and do this with me. All right. Then it says on the second circle, draw 3 points. Connect the points with line segments. So now we're going to draw 3 points. And when it says connect the points, it means connect all the points. All right. Okay. Follow this pattern. So on the third one, right, on the next one, we are going to draw 4 points. And we're going to connect them all. Now don't forget about this one here, right? and we'll follow this pattern. So it says count the number of regions into which each circle is divided. For example, the first circle is divided into 2 regions. All right. So this would be like the first region, that would be the second region, right? So we go to the next circle. All right, how many regions do we have? We have 1, 2, we have 3 in the middle, and then we have 4. All right, so this one has 4 regions. The next one we have 1, 2, 3, 4, 5, 6, 7, 8. All right, we have 8 regions, and actually didn't do this circle, so let's do that. So we got 1 point, 2 points, 3 points, 4 points, 5 points, right? So now we want to connect all of these. So oops. All right, so we connect those points. So now how many regions is this divided into, right? It's getting kind of hard to count. So let's go through. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. All right, 16 regions when we have 5 points. So I want you guys to look at what we just did there. All right, look for a pattern, and I want you to make a conjecture. Okay, a conjecture is a statement that you think is true based on the evidence that you have. So I want you guys to go ahead and pause the video and do that now. Okay, so hopefully you've got a conjecture written. All right, now the next thing that you're going to do is you're going to test your conjecture. All right, using 6 points. So we're going to draw 6 points onto this circle. Your points can be anywhere on the circle. You know, they don't have to be in the same spots mine are. 4, 5. Oh, I don't know how you guys write with your fingers so much. 6. All right. And now we need to draw as many points as we can. So, as many connectors as we can. So I just start from a point, you know, and then go to all the other ones that I can. Did I do them all? Oh, nope, I forgot this one. Okay. So now we're going to count, all right? Now this is going to be a lot. So we're going to test our conjecture. So we've got 1, 2, 3, 4, 5, 6, all right? 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, and then right here in the middle, we have 31. 31 sections in this triangle. So does this support or disprove your conjecture? All right, so whatever your conjecture was, does the fact that when we had 6 points, that created 31 sections, does that support or disprove your conjecture. So I'm going to end it there. All right. I don't know what your conjecture was. When we come into class, I'm going to have you guys share your conjectures that you made, and then we're going to kind of talk about the implications of this. So if you want to go ahead and onto your practice and try and do what you can, go for it. All right. That practice is going to be due on Sunday at midnight. So if you have any questions, all right, bring them to class. And other than that, have a great day.